Hello, wonderful Java learners. Welcome to another exciting tutorial. Today, we are going to unravel the fascinating world of the Java Reflection Application Programming Interface. Imagine being able to look inside your Java programs while they are running, not just at the code you wrote, but at the very structure of your classes, methods, and fields. That is exactly what reflection allows us to do. It provides a powerful way to inspect and even manipulate classes, interfaces, fields, and methods at runtime. This capability is crucial for many advanced Java applications, like frameworks and testing tools. In this beginner-friendly session, we will understand what reflection is, how to obtain class objects, and how to inspect and invoke members dynamically. Let us dive in. Our journey into reflection begins with understanding the class object. In Java, every time you define a class, the Java Virtual Machine, or JVM, creates a class object that represents that class. Think of it as the blueprint or metadata for your class, available right there at runtime. This class object is your gateway to all reflection operations. There are primarily three ways to obtain a class object. First, you can use the .class literal, like string.class. Second, if you already have an object, you can call its getClass method. And third, for dynamic loading, you can use class.forName, passing the fully qualified class name as a string. Let us look at a quick example to see these in action on our whiteboard. Now that we know how to get our hands on a class object, what can we do with it? Well, the class object allows us to inspect its members dynamically. This means we can discover its fields, methods, and constructors at runtime. For example, methods like getDeclaredFields will give you an array of field objects representing all fields declared by the class. Similarly, getDeclaredMethods returns an array of method objects, and getDeclaredConstructors gives you constructor objects. It is important to remember the difference between get methods and getDeclared methods. Get methods typically return public members, including inherited ones, while getDeclared methods return all members declared directly by that specific class, regardless of their access modifier. Let us see this in a code snippet. Inspecting members is great, but the true power of reflection comes from manipulating them. This means we can dynamically create new instances of classes, access and modify fields, and even invoke methods at runtime. Imagine you have a method named sayHello in a class, and you want to call it without knowing its name beforehand, perhaps reading it from a configuration file. Reflection makes this possible. We can get a method object for sayHello, then use its invoke method, passing the object instance and any required arguments. We can even invoke private methods or access private fields, though this requires setting setAccessible true and should be used with caution. Let us walk through a practical example on the whiteboard. While reflection is incredibly powerful, it is also a double-edged sword. There are common pitfalls and important considerations. First, reflection operations are significantly slower than direct Java calls. So, avoid using reflection in performance-critical code if there is a direct alternative. Second, reflection breaks encapsulation, allowing you to access private members. This can lead to security vulnerabilities and make your code harder to maintain and understand. Third, you must handle various exceptions like class not found exception if the class is not found, no such method exception if a method does not exist, or illegal access exception if you try to access a private member without set accessible true. Always use reflection judiciously and only when absolutely necessary, such as in frameworks or specialized tools, not for everyday programming tasks. Alright, my dear friends, we have covered a lot about the Java Reflection application programming interface today. We started by understanding that reflection allows us to inspect and manipulate classes, fields, methods, and constructors at runtime. We learned how to obtain a class object, which is our entry point. Then, we saw how to inspect various members like fields and methods, and finally, we demonstrated how to dynamically invoke methods. We also discussed the important considerations, its performance overhead, and the need for careful exception handling. Remember, reflection is a powerful tool for building flexible and dynamic applications, but it should be used wisely. Keep practicing and exploring. If you found this tutorial helpful, please give it a thumbs up, share it with your friends, and do not forget to subscribe to our channel for more exciting Java content. Happy coding!